We're going to go over a very simple way of getting to name coordination compounds. The first we have here is name the following compounds. The first one. Now, if we look at the first compound we have, that is CO, NH3, 5Cl, Cl2. So, just like we name just ionic compounds, we first start by naming the thing which is positively charged and then the one which is negatively charged. So we first name the cation before naming the anion. In this case, the thing which has been mentioned first here is the cation. So that's the one we are going to name first before we can name the anion. But as we get to name this compound here, because this is a coordination compound, it is made up of a complex ion and also a counter ion. This compound which we can see at the very beginning here is the complex ion. This is the counter ion. Now a complex ion itself is made up of a ligand and a metal. So as you get to name this, you are going to first name the ligand. And then you are going to name the counter ion. We'll then name the metal. So that is how we're going to go about that. And then at the end, name also the anion. Now first we need to determine what the charge of this metal is. So cobalt plus, we have got 5 ammonium. So each ammonia is the neutral molecule, so the charge is 0. And then plus, how many chlorines we have? We have got the 3 of them. Chlorine is in group 7, so the charge is -1. And this is supposed to add up to what? To 0, the charge. Because it's a neutral molecule. It's not charged. So this will give us cobalt having a +3 charge if we take the -3 the other side. Therefore now we can name it. So the name here is going to be, first we're going to name the ligand. A ligand is simply a group of atoms or an atom with a lone pair of electrons where a metal can attach. So the ligand, how many are there? There are 5. So we're going to put the prefix penta. So this is going to be penta. Now this is the ligand ammonia. When we are naming ammonia as a ligand, we say amine. So it's going to be pentaamine. There's no space. Pentaamine. And then we go to this, that is chloro. And then now we come to this one. Now, this is cobalt. But when we are naming a metal which is on a ligand, we're just going to say cobalt. But it's different when this metal was this side, when it was acting as an ion. So we need to get that difference. So this is going to be cobalt. What is the charge? That is the one, or the valence, secondary valence. So the charge is 3. We put it as a Roman numeral, and then now we can name this one. That is simply a chloride. So therefore the name of this one is pentaamine chlorocobalt 3 chloride. What of the second one? If this is the first one, what of the second one? Second one, we have been given potassium, iron, and then a cyanide. We also need to find out. Now here we first named the cation, the anion I mean. The anion in this case is not where the ligand is. We can see a ligand is here with its metal. So this is a complex ion, and here is just the other element. So in this case, the ligand is an ion. So first name this one, and then name the complex ion. But you need to first find out the oxidation state for ion. We have got 3 potassiums, and we know the potassium each is +1 charged, and then plus ion, which we don't know the charge, plus 6. Cyanide is having a -1 charge. This should give us 0. So this is 3 minus 6, giving us a -3. Taking the other side, it will be +3. So that's the charge of ion. So therefore, when you are naming, since here we are first naming the cation, that is the one which is positively charged. So that is potassium. And then now we can name the anion, starting first with the ligand. So there will be a space because we are separating an anion and a cation. So potassium. Now we have got 6 cyanide, so that would be hexa cyanide. Whenever we are naming the ligand, or whenever we are naming compounds this side in the ligand as anions, instead of us saying cyanide, we are going to say cyano. So we name cyanide as cyano when it is acting as a ligand. And then we have got what? Ion. Now, when ion is in the anion, it is part of the thing which is negatively charged. The whole this thing which is negatively charged will not name it as ion. It is ferrite. Just like copper, when it is on the part which is negative charge, it's not copper but copperate. Gold is orate. Just like that, even other compounds such as silver, we're going to name it as agitate, gold, orate, tin, stannate, like that. So lead as plumbate. So this will not be iron but ferrite. And then we are going to put the charge, which is a 3. So that's a name: potassium hexacyanoferrate. Let's go to this one. Name the following. We have iron, and then we have got ethylene diamine, and then N2, 2, 2, and then a sulfate. How do we name this one? So here is the cation, the anion this side. So we need to find out the charge first for the metal which is present. So that's ion. Ion plus we have got 2 multiplied by 2, that is a 4. So we have got 4. Actually, this 2 is also multiplying the ion, so I'll also put it in front. We have got 4. Ethylene diamine, the charge is 0, it's a neutral molecule. And then plus we have got 2 times 2, which is also a 4. The charge of a nitrogen dioxide, that is a negative 1. And then plus we've got a sulfate. A sulfate has a negative 2 charge. This should give us 0. So this will give us 2 ion. This is negative 4, this is negative 2, that will give us negative 6. It goes the other side, positive 6. Dividing by 2, that will give us positive 3. So therefore the name, now we start always with the ligand. The ligand in this case is ethylene diamine. Now we have got the 2 of them. So we are supposed to name it as di. But because in the name it is already a complex name, ethylene diamine, there is already di inside. So we'll not name it as di. Instead, we are going to be adding special ones such as bis, tris. If it is 4, that will be tetrax. So this is what we add when it is a special case where we already have di, bi, and such things. So because there are the 2 of them, we are going to use bis. So this is going to be bis, and then we name the ethylene diamine in brackets. Ethylene diamine. And then we can now name this compound. We can see that even for that one, there are the 2 of them. So we have got 2NO2. So we're going to name it as di. Now, this is nitrogen dioxide. When we are naming it, we just name it as dinitro. Okay, it is a nitrozyl. When we have got this compound nitrogen dioxide, we are naming it as a ligand. It's a nitrozyl. So we have got 2 ligands in this case. So when you have got 2 ligands, when you are naming them, you name them in alphabetical order. That's why I started with the ethylene diamine because of E, and then named the nitrozyl is N. So there are the 2 of them, so we'll just say dinitro. When you have got compounds like this, we add an O when they're acting as a ligand, dinitro, and then we can now name the ion. In this case, ion, we just name it as ion, not as ferrite. Why? Because it is on the cation, not the anion. So that will be ion. The charge on ion is a 3, so we use a Roman numeral, and then we name the sulfate. There should be a space. So therefore the name is bis ethylene diamine dinitro ion 3 sulfate. And then now we can go to the second one. The second one, we have sodium 2 and then SnCl6. So we can see that in here the complex ion is what? Is a anion. So yeah, it's a anion. It's negatively charged. That's why it's named. It's coming out second there. So we're first going to name this compound which is here, which is the sodium. Now let's first find out what the charge for this one is. That is the charge for, that is what? Sn, that is the symbol for tin. So we have got two sodiums and the charge of each is positive 1 plus 13 and then plus 6 chlorines is negative 1. This should be equal to 0. So this will give us, this is a 2 minus 6, that is a negative 4. Going the other side becomes positive 4. So that's a charge. So first name the sodium. So that is sodium. And then we'll leave a space and name now the complex ion. Starting with the ligand, we have got 6 chlorine. So that will be hexa. That is going to be named as a chloro. Whenever we are naming these compounds as ligands, we put an O at the end. Chloro. And then we can name now the tin. Now when you are naming tin, if it is found in a negative portion, we will not name it as tin. That is stannate, just like copper and others. And then we put the charge as a Roman numeral 4. So that is the name. Sodium hexachlorostannate 4. Let's look at this one. The first we want to name is the one on top. So we can see really that for A, here is the complex. The complex ion is the O of this one. Together with the chromium, the ligand is here. So let's find out the charge of the chromium. So Cr plus, we have got 4 water molecules. Water is a neutral molecule, so 0. Plus we've got how many chlorines? 2 plus this one 3. So that would be 3 chlorines each with a negative 1 charge. That would be equal to 0. So chromate, we are saying that it's going to be equal to positive 3. So to name it, we are going to start with the water. There are 4 of them, so we're going to put tetra. Now when we are naming water as a ligand, we don't say water, it is aqua. So tetra aqua, and then we name the chlorine as chloro because it is in the ligand, chloro. And then it's not really like it's in a ligand, but it's on the anion, on the cation, I mean on the positive part. Okay, that is tetra aqua chloro. And then we name the chromium. Chromium, what's the charge? That is 3 using a Roman numeral. And then we put now the chlorine, which is negatively charged there. Okay, so that's the name, tetra aqua chloro chromium 3 chloride. Now let's consider B. How are we able to name also B? So you can try to pause the video and see if you are able to work it out, and you can confirm. So in this one, we've got platinum as a metal. So we're going to find this oxidation state. So we've got platinum plus, we have got 2 ammonia, the charge is 0, plus we've got 4 chlorines with a negative 1 charge, should be equal to 0. So I find that platinum should be positive 4 charged. So first name the ammonia, there are the 2 of them. So that is going to be what? We are going to use di. So we have got di, but ammonia, we don't name it as ammonia. How do we get to name it? We name it as the amine. So that would be diamine. And then we go to the chlorine. We add the O because it is on the part which is positively charged. Diamine chloro. And then we can go to platinum. So we are naming it as platinum, not anything else, because it is on the part which is positively charged. Otherwise, if it was on the negative portion, it wouldn't have been platinum. Would have added an AT, so platinate. So this is diamine chloro platinum. The charge is 4. And then okay, that would be it because we don't have anything else to name which is outside here. So diamine Chloroplatinum. Let's consider C. So in the same way, we're supposed to first find out what the charge of the metal in this compound is. So in this case, the metal that we have is what? Cobalt. So now, what is the charge of that metal? So let's go on. So I've got cobalt plus, we have got 2 water molecules and the water is 0 charged. And then plus we've got 4 ammonia, it is also 0. And then plus what? We have got only 1 chlorine and it's negatively charged. So we're saying that cobalt here is going to have a positive 1 charge. Okay, that is the charge of cobalt in this case. Now how do we get to name it? We are going to, now if we can see also here we have got, we don't have only one complex ion, or we don't have only one ligand. So as we get to name these ligands, we are going to name them also in alphabetical order. Okay, so we are going to start. Now we have got water, which we name as aqua, and then we have got amine there. So which one comes first? We can see A and A is the same, but M comes first before Q. So we're going to first name the amine. So this is going to be, but how many are there? There are 4. So that will be tetra amine. And then how many water molecules do we have? We only have 2. So that is going to be diaqua. And then we go now to the cobalt. Cobalt. What's the charge of cobalt? What have we found out? So that has given me a 1. So that is cobalt 1 and then chloride. So that is it. So we can see if this was a 3 here, and then the charge of cobalt would have been also 3, so we could have said cobalt 3 chloride. Now let's look at this one. We have potassium PtCl5. How can we name it? As simple as it looks. So we can be able to try it out before we even get to see the answer, and we can now confirm if we have worked out what is true. So let's look at it now. So in this case, this compound we can see here is the one which is negatively charged. We have got a ligand and also a metal. So let's find out the charge for platinum in this case. What is it going to be? So we have got first potassium is only 1. The charge of potassium is a positive 1 plus platinum, and then plus 5 chlorines, and the charge of 1 is negative 1. This should be equal to 0. So platinum is giving us 1 minus 5, that is a negative 4. And then if we get to take that over the other side, it's going to be what? It's going to be a positive 4. So to name this, we first start with the potassium. So that would be potassium. And then we name the ligand. There are 5 of them, so that is going to be pentachloride. Okay. Not pentachloride, but pentachloro, because that's a ligand. Pentachloro. And then we name now the platinum. So now, because platinum in this case is not just alone, but it is acting as, it is on the portion that is, if we can say this portion, the second one to be mentioned is a portion which is negatively charged. So that will not be named as platinum, but as a platinate. We put an ATE at the end. What's the charge here? It is a 4. So that will be platinate 4. That's a name. So let's look at another one. This one. We can see the metal here is cobalt, so we need to find out its charge. So we've got cobalt plus 6 water molecules which have got a charge of 0, and then plus fluorine is in group 7, so that's a negative 1, should be equal to 0. So cobalt is giving us a charge of positive 3. So start naming first what is inside. That is aqua, but there are 6 of them, so that is hexa aqua, and then cobalt, the charge is 3, Roman numeral 3, and then fluoride. So that is the name for that one. What of here? Give the formula of the following. The first one we have is triamine bromoplatinum 2 chloride. Triamine bromoplatinum 2 chloride. How can we name it? So first start, the first given us triamine. We know what an amine is. That is simply ammonia, so that is NH3. Tri means there are the three of them. And then now we can put bromo, and that is supposed to come on this side. Okay, bromo, platinum 2. So now the platinum, we are going to put it in front. So the metal always comes in front of the ligand. Okay, like that. And then we have got a chloride at the end. But we've been told that platinum has a charge of what? Has a charge of 2. Now, how do we know how many chlorines to put there? How do we know that we're supposed to add 1 chlorine, 2 chlorines, or something like that? How do we know? So what we are going to do is, we are going to get this. We have got platinum. They have told us the charge is what? Positive 2. So because it's a metal, that's why I know it's positive, not negative. So positive 2 plus the charge of ammonia, we've got 3 ammonia molecules, the charge is 0. And then plus we have got 1 bromine. Okay, so bromine, we know the charge is what? A negative 1. And then plus the charge of chlorine, this should give us a 0. So this is a 2 minus 1, that is a 1, plus the charge of chlorine, that should be equal to 0. So if we take chlorine, the other side, chlorine is going to be equal to negative 1. So it is only 1 chlorine that gives us a negative 1 charge. Otherwise, if we wanted a negative 2 charge, then it should have been 2 chlorine. So that is how we get to determine that. Now let's consider the second one. We've been given potassium, so that one is the first one we're going to name. And then hexafluorocobaltate. Now we have hexafluoro. How do we name that? So let's first start. Hexafluoro. That means we've got 6 of them. And then cobaltate. So that is simply cobalt, like that. The charge we can see is what? Is a positive 3. Now, how do we know how many potassiums do we need to add? So the charge of potassium plus the charge of the cobalt, that is positive 3, and then plus we've got 6 what? 6 fluorines, each has a negative 1 charge, should give us a 0. So this will give us potassium 3 minus 6 negative 3 is equal to 0. So potassium is supposed to be equal to positive 3. The only way it can give us positive 3 if we have got the 3 of them, because 1 potassium gives us what? A 0. I mean a 1, because potassium is in group 1. Okay. So that's the formula then. Now let's consider also C, sodium trinitrosyl acetate. How can we be able to work out that one? Okay. How do we work it out? Now, to work this one out, what we are going to do is, we are going to get, first we've been given sodium, so we're going to write the sodium there. And then we have got trinitrosyl. Nitrosyl is the name for nitrogen dioxide when we're using it as a ligand. And then we have got acetate. Now, acetate, that is the name that we use when we are referring to silver, when we are talking about it as something that is negative. So I've got silver here. So the whole of this thing is what is acting as negatively charged, this thing which is here. Now I've been told trinitrosyl, so the nitrosyl is supposed to be the 3 of them, so I'm supposed to add the 3 here. And then acetate as a 1 charge. So how do we know how many sodiums we need to use? Sodium plus silver, the charge is positive 1. We can see they've already told us even here. And then plus we have got the 3 nitrosyls, but 1 gives us a negative 1 charge. This should give us a 0. So sodium 1 minus 3, that is negative 2, should be equal to 0. That means sodium should be equal to positive 2, and the only way it can be positive 2 if this is a 2. So that is going to be the formula then. And the last question here, name the following compounds, and the first one we have there. So if we look at this compound, we've been given silver as the one which is positively charged. So to name it, simply that is going to be silver. Now, what's the charge of silver? You know, silver is one of the group D elements. And in this case, what's the charge of silver here? So silver has got a positive 1 charge. Okay, silver has a positive 1 charge. We are naming it as what? We are naming it as something that is positively charged. So we can just show that positive 1 charge. But if it was a group 1 element, if it was not a group D element, we wouldn't have even shown this. Like sodium, chlorine, bromine, sodium, potassium, group 1 elements. We don't even show those. Maybe even group 2 elements, we couldn't even have shown that, because it's a group D element, we are showing that. And then now we go to the complex ion. On the complex ion, what we have first is we have got 4 iodines. So what will be the charge of mercury here? So I've got 2 silver, and the charge of each silver is a positive 1, plus mercury, and then plus we have got 4 iodine is a negative 1 because it's in group 7, should be equal to 0. So this is a 2 minus 4, which is a negative 2. Taking the other side becomes a positive 2. So that's the charge of silver. So when you are naming this portion, you first start with the ligand. So that would be silver. Ligand is iodine, but we have got the 4 of them, so that would be tetra. But whenever we are naming these ligands, we put an O at the end. So instead of iodine, it will be iodo. Okay, iodo, and then we can name the mercury. Now, because we are naming the mercury as a part which is negative charge, it will not be mercury. It will be mercurate. We add an ATE at the end. So that will be mercurate. And then we just put the charge, that is a 2. So the name is silver 1 tetraiodo mercurate 2. Now, the last one, which is platinum, and then we have got 3 ethylene diamines, and then we have got bromine. So we need to find out the charge of the platinum. So we've got platinum plus 3 ethylene diamines, but each ethylene diamine has a 0 charge, and then plus we've got 4 bromines, each with a negative 1 charge, that should be equal to 0. So platinum is going to give us a positive 4. So first name this ethylene diamine, but there are the 3 of them. Okay, the 3 of them. So we're supposed to say try. But because this is already something that is already complex, ethylene diamine, there's already a di inside. Instead of us saying try, we're going to say tris. So this is going to be tris, and then ethylene diamine. And then we can now write the platinum. It will not be platinate, it will just be platinum, because we are not naming it as part of the compound which is negatively charged. Platinum, we put the charge, that is a 4, and then bromine, but we'll not name it as bromine, but as bromide. Okay, so that is the name for that one. Thank you so much for watching the video. If that was helpful, please be sure to subscribe. Enjoy your day.